Hi all. So today what I'm going to discuss is this question. Okay, yes, this question, right? So the question states, the question name is max chunks to make sorted. Okay, so we can see we need to find the maximum number of chunks. Okay, to sort the array, right? So what that means? That means okay. Let me open my, let's say, notepad. Let's remove it. Okay, so see, first of all, we are given an integer array of length n, right, that represent a permutation of integers. That means the integers from 0 to n minus 1. Okay, say here the number of elements are 5, right? So here the elements should be from 0 to 5 minus 1. That means till at max we can go get is a 4 here. Okay, the maximum element. So that is written here, and we need to split the array into some number of chunks. Okay, we need to split the array into chunks, that means some partitions, and individually sort each of the chunk after concatenating them, the result should be equal to the sorted array, right? And we have to return the largest number of chunks that we can make to sort the array, right? So what does that mean? Taking this example, we have this example, right? Okay, it is already explained here. So it is 4 3 2 1 0. We need to sort this array. So how can we sort this array? Simply 0 1 2 3 4. Okay, so that is the simple method, but here we need to uh, break it into chunks, that means in some partitions. Okay, and in such a way that we can concatenate that partitions together, and that should uh, give the array in the sorted format. Okay, so here what is given, that splitting the array into two or more chunks will not return the required result, right? Why? See, for example, if they split the array into 4 3, 4 3 2 1 0 2 1 0. So if we sort this chunk, the 4 3 will be sorted as 3 4, and 2 1 0 will be sorted as 0 1 2. So the final array, the final array will be, sorry, so the final array would be, see, first 3 4 is sorted. Okay, then 2 1 0 is sorted as 0 1 and 2, right? So is this a sorted array? No, right, this is not a sorted array. And one more thing, I think they have not mentioned here, that we cannot interchange the relative position. Say 3 4 chunk 3 4, okay, or say 4 3 was before 210. Okay, then it came to 1 0. Okay, so if we sort the first chunk, that is 3 and 4, after that we sort the second chunk, that is 0 1 2. So we cannot say that this the second chunk will come before this chunk, right? That should not be the case. We simply have to maintain that relative ordering of the chunks, correct? So maintain relative ordering of chunks, correct? Okay, now I'm deleting this, and now we will now I will show you uh, the most efficient way to solve this question, right? Okay, so sorry, see, let us say we have the same array, correct? Correct, right? Or let us say okay, let us take this one. Mark the indices 0 1 2 3 and 4, correct? Right, now we have our pointer I or k, okay, on the 0th index, correct? And the element is equals to 4. Okay, now we will make one more variable, say max, which will be stored. Right now max is null, or let's say negative, correct? So now when we traverse this element, we traverse this element at the 0th index, so max will become this one. Okay, we update it. Max is either max of math dot max, max of max, and let's say e, correct. So e is 4 and max was 0 initially, sorry, negative initially, so negative and e, obviously the e is greater than negative 1, so max will be equals to 4, right? So right now max is equals to 4, correct. Max is equals to 4. Now see, now we do k plus plus, k goes to here. Again we see that max is 4 and the current element is 3, so we will say still max will be equals to 4 only. Now again we do k plus plus, now element becomes 2 and again max is 4 only. Now we do k plus plus, element becomes 1. Now again we see that max will be 4 only, right? Now when we do k plus plus, we see here that k is pointing to 4th index, okay, and here we have the element as 0, correct. So max will be 4 only. Now one catch here is, see, total elements we have is n elements, right? And what is the ordering that we say, that 0 to n minus 1 elements, okay, we have n elements, but the value, see the value, this one, any element will be between 0 to less than n. Less than n means at max n minus 1, okay. Here we see that 5 elements are there, 5 minus 1 4, so 4 will be the max element present here. So here also we see that 4 is the maximum element present here. So n is equals to 0 to 4, correct, inclusive, 0 to 4 inclusive, correct. Or we can say 0 to 5 but excluding 5, right? This one is also a correct syntax. Now see, so 0 to 4, let me write 4 only, that was much clear, okay. From 0 to 4, when k is present on the 4th index, okay, 4th index, we can say that all the elements from 0 to 3 is in between, before 4 already has arrived, okay. And we can also say that at 4, at max, we can get this element, okay, or this element would have been processed before 4 also. That means here also we saw that the 4 was maximum element was present at 0th index, okay, that is also okay. But we can say that before or at 4 we would have got our maximum element, okay. So when k index is at the, say, k is equal to max element, okay, k, or say max element is 4 and the kth index is following on that index only, so in that case we can say one chunk is completed. So let's say chunk was equals to 0. So when we say that max value and k's value is equal, that will be a condition. If max is equals to k, then we will increment our chunk, then we will do chunk plus plus, correct. So this is our algorithm, correct. This is our algorithm, this 4 liner, right? Now let us take one more example. This was a little like very quite simple one, so let us take this one, okay. Then we will take one custom example. Say this is our array, right? We have our elements indexes 0 2 3 4, correct. K is pointing here. Now when we say max is equals to 1, right? Okay, max is equals to 1, correct. When max is equals to 1 and k is equals to 0, right? So at 1, at 0 index, at 0 index we got 1, right? but 0 and max are not equal, correct? At index 1, at index 1 we have 0, okay, and max is 1. Okay, so max and k both are equal. So what we can say, at index 1 we have covered all the elements that can be that are between 0 to 1, right? At index 1, what are the elements that we can get? Say n was equals to 1, okay, so the array would have 0 and 1 only at max, or we can say 0 and 0 only, sorry, 0 and 0 only, okay. But at max we could have got either this one or this one, sorry, or this one, or 1 1 or 0 0, okay. But here the condition is 1 0, okay, this is our condition. So we can say that 1 and 0 both have been covered here, okay. Since both have been covered, and max, and we have got our max element as 1 also, and k is also 1, so we can say that 1 has already been occurred, so our first chunk is completed. Okay, that's so simple. Chunk is equals to 1. First it was 0 when we saw that max and k both are equal, so we can say that this chunk is completed, so we can say chunk 1, chunk incremented, so we can say this is one chunk, okay. Why we are doing this? We could have simply say that go and check for 4, okay. Okay, that also we could have done, but that maximum number of chunks we have to get, the maximum number of chunks, for that we have to do this, okay. Now k plus plus, here the max element would be 2, okay. Now we see that k is also 2 and max is also 2, so I will also write here the chunks for more clarity. Chunks, first chunk is 1 0, right? Second chunk, see here what we saw, that max is 2 and k is also 2, okay. Since, and we now, by now you have understood that if both are equal, we'll increment our chunk, so we got another chunk, so that chunk is simply 2 only, that chunk is just 2. Now we increment k, now here we got 3, so, and max would also be 3, because in between 2 and 3, 3 is the greatest one, and index is also 3, so chunk will also increment to 3, correct? And we have already taken this chunk here, so what chunk is left? 3, okay. Since we incremented our chunk, so one more chunk should be added here, so 3 chunks are added, this. Now we increment our index, the element we got is 4, and the maximum till now we have got is 4 then, and now index value is also 4 and max value is also 4, so simply increment our chunk. Now increment our chunk, so we need to add one more chunk, so till here we have added all the chunk. What is the left chunk? Only 4, so one more partition that we will add here is 4, okay. So total number of chunks we got is 4, right? I hope this is much clear now. Now let us take an more example. Let's say 5 2 1 3 4, say 4 1, and say 0. So here what are the elements? 0 1 2 3 4 5. So n value, n is equals to 6, okay. So the elements present would be in inclusive range of 0 to 6 minus 1, that is 5, correct? And also we can see that max element is 5 only, and minimum is 0 only. We cannot say that minus 1, that is absurd, see, because it has been already been mentioned in our constraint. So at least 0 will be there, and at max n will be there, and minus 1 will be there. So this is an absurd question, okay. Now see, chunk is equals to 0, correct? Max is equals to, right now let's say negative value, or let's say simply we will add our indexes 0 1 2 3 4 5, correct? K is here, that means our index is there, right? Now what we'll see, k is equals to 0, and at 0th index we have got the element to be 5. Okay, at starting only we got that our element is 5, correct? So since 5 and k's value is 0, so simply we'll update our max, not our chunk. Okay, because k and max are not equal, correct? Simply we do k plus plus, k is 1 and max is 5 only, so simply do k plus plus, k is 2, max is 5, simply k plus plus, k is 4, max 5, simply k plus plus. Here also max is 5 and k is 4, simply k plus plus. Now here we see that k is 5 and max is 5, so here we'll increment our chunk to 1, correct? Right? Now why we did that? Because see here there is no other option to sort this array as a whole. As a whole it will sort, that means this whole is a chunk and wholly we will sort the array. So after sorting we'll get 0 1 2 3 4 and 5. Okay, why can't we say that sort this 3 then this 3? Simply we see that if we sort this chunk, so that chunk will be 2 3 5 and here we will get 0 1 and 4. So we cannot sort this chunk together to get the 0 1 2 3 4 5, right? I hope this is clear. Now this was quite simple, just like this one only. Okay, let us make it a little complex. Here I'll add 3, here I'll add 4, here I'll add 2, here let it be, let us say 5 now here. Now okay, now it is done. Now we see chunk is equals to 0, max is equal to 3 right now. Why? K is at 0th index and 0th index value is 3 and max and 0 are not equal, so simply increment k. Now the max value we got 4, so increment max to 4, k plus plus, k is 2, max is 4. Now k plus plus, let us change this value, so let us say 1 and 5. Okay, now see, k is simply this one also we have to change to make it a little different example, otherwise the same result will come. Okay, now see, k is 3 and max is 4. Now do k plus plus, now k is 4. Now here we'll see that k and 4 are max are equal, so we will increment our chunk here. Okay, so what chunk we got here is 3 4 2 1 0. This is one chunk, this is one chunk that we got, 3 4 2 1 0. And if we sort this chunk, we will what will get 0 1 2 3 4, right? So see, till 4 we can see that all the elements that are less than and equal to 4 are present in this chunk. So that is the concept behind this approach. Okay, that means at whatever index I am standing, all the elements are covered between 0 to that index itself in that chunk. Okay, so that can be sorted here. Okay, correct, it has been sorted. And now when I am at 5, we got our index, sorry, the element is 5, so we will increment our max to 5. And since k and max are equal, so this is another chunk that is possible. So simply this chunk is possible and I'll increment this to 2, correct? And if we join this one, so we will get a sorted array, correct? Right, so this is the beautiful concept behind solving this question. And see, this is a very small code, very small code. Okay, I hope the intuition is very clear to you all. Okay, see, okay, first what we did, chunks is 0, max element is 0, and now in each iteration we are checking our max element, just like what we did here. Each time we were checking our max. Here max was 3, now max was 4, till index 4 we got 4. Okay, what if 5 was there? If 5 was there, then max would also be 5. Okay, then we will not increment chunk would have been 0, correct? And when k goes to index 5, max was 5 only, and then max and k is equal, then we will increment our chunk. So that means at whole this array is one chunk. Okay, so at whole this array has to be sorted. Okay, that is the beautiful concept behind this question, right? So we are checking our max, and if max is equals to the index, we simply do chunk plus plus, and at last we will return our chunks. So simple, correct? And it is, we are able to submit it also. And see, what I did wrong here, I was thinking of a very different approach. So if I is equals to 1 to 0 n, see, we need to understand our uh, what where we failed. Okay, so at here what I was doing, I was saying that this one would be a chunk itself in the beginning only, but that is not the case. Okay, so if we give some time to the question, then we will be able to understand that this is a very simple question. Okay, so I hope you understand the solution. Thanks for watching. I'll paste the link in the description. Thank you.